Hi and welcome, ladies and gentlemen. Today we are talking about Preorder Traversal. As usual, you find the source code of my programming at the end. In the description below there is a link to my GitHub repository. Alright, the Preorder Traversal of a binary tree works in that way that we want to print the root first, then we want to go through the left subtree, and then we want to go through the right subtree. Well, so if we have a look at an example, if we have here our tree, then we have at first our first tree here, that is 1, 2, and 3. And with a recursive definition, we always find that every tree has a root node and it has 2 children. So we have the left subtree here, that is 2, 4, and 5, and the right subtree here, the 3, 6, and 7. Alright, if you want to have a look at an example, then we go in and have a look at our 1 first. Since we want to print the root node first, we can now go ahead and say, okay, we worked on our 1 and then we can print our 1. In the next step, we go to our left subtree. There we have the 2 as a root node and we work on that so we can now append the 2 to our result. And we can go further to our next left subtree, and that is the 4. Alright, once we are at the 4, we are done because that is a leaf. We can here append it to our results. And since we've done the root already of this subtree, we can go to our 5 then. That is the right subtree of this root node of the 2, 4, 5 subtree. Alright, so the root node is a leaf node, so we are done with it and we can append it to our results. And in the next step we go back to the 1 because we have to do the right subtree there. So we go to the 3, the 3 is a root node, and in Preorder Traversal again we work on the root node first, so the root node is here appended to our results. Then we go again to the left subtree, which is a 6. The 6 is a leaf, so we can append it to our tree. And then we go to the right subtree, which is a 7, and then we can append that also to our results. Alright, when we have a look at the algorithm here, then we have our empty result list first. And we check if the node is a leaf. If it is a leaf, we return a singleton list with this node. Then we go in and we can already append the root node to our result list. And then we want to go through the left subtree and want to invoke this Preorder Traversal on this subtree again. Alright, and in the end, we do the same with our right subtree and then we return our result. Alright, let's have a look at the implementation in Python. For that, I want to create a new file here and I call that preorder_traversal.python. And for that, I want to use an earlier episode where I explained the binary trees as a list representation, and for that I want to copy this source code quick here and paste it here. This tree is based on this node class here, where we have a left subtree, a right subtree, and then a value. So that is the most important point, and then we have here our root node. We can insert data and some stuff. I just recommend watching this video about the binary tree as list. Alright, so here at the bottom I want to create our method for the Preorder Traversal. So I say here def Preorder Traversal, and that gets just self as an argument because we want to do that in a recursive manner to run through all the nodes. Alright, and here I say invokes the pre-order traversal on the tree, and I say returns a list of nodes in pre-order traversal. And for now I just want to say pass here because the main part will happen recursively. Therefore I create another private function and I call that preorder traversal rec for recursive, and that gets self and it gets the node it currently works on. Alright, so we need at first our result. That will be a list here. And then the next step is to check whether our current node is a leaf node. So if node.left equals to none and our node.right equals to none, we initialize them as none. So we can ask here, and if we don't set anything there, these have to be leaf nodes. Then we can return our singleton list, and that will be here our node. So we are done with this node. So the next step in our preorder traversal is to append the root node of each subtree to our list. And there we say here result.append node. In the next step, we want to run through our left subtree if it exists. So we say if node.left is unequal to none, then we want to invoke our preorder traversal again. So we say here self.__preorder traversal rec on node.left. And we will get back our result of the subtree there. So we say here result.extend with that. So what we have now in our result is the result of the traversal of the left subtree. And once we've done that, we do exactly the same again on the right subtree. For that, I go in here and I say here if node.left, we have to replace the left with right in both occasions here. So we say here node.right. What we have to do now is we have to invoke our recursive version up here in our preorder traversal method. So we go there and say return, because we will get in the end a list of our results. And we also have to return these down here. So return result, otherwise we don't return anything, we just return none. And up here we have to return what we get back from the invoked preorder traversal recursive version. So here we call self.preorder traversal recursive and we start with our root node. So here we say self.__root. Alright, let's see if that works. What we get back is a list of nodes. So we go in and say for node in, and now we call our bin tree, that is the instance of our binary tree dot, and there we have preorder traversal, and that will give us a list of nodes, and then we want to print here our node.value. And what I want to do here is just that it looks a little bit better. I want to print an empty line so that we have a separation between printing the tree and what we've done before to here printing the preorder traversal. So let's run that and have a look how it looks. So we go in here, that is our tree as we had it earlier, I have to say that. So we print the root node, that is 1. Then we go to the left subtree, there the root node was the 2, and that is fine. Then we go to the left subtree, which is a leaf, and that was 4. Then we go to the right subtree, which was a leaf and is 5. Then we go to the right subtree of our overall tree, which had the root 1, and that was here the 3, which with the children 6 and 7, 6 here again as a left leaf, and 7 as the right leaf. Alright, ladies and gentlemen, that was it for this video. Tell me down in the comments, please, what you think about it, and give it a thumbs up if you liked it and if it was helpful to you. I really appreciate every subscriber on this channel, so subscribe if you want to get informed whenever I'm uploading new videos. So that's it for me. Have a great day. Bye.